Hello everyone. So in this video, let us talk about a very simple yet effective program to first understand about Go routines, and then we'll move down to the actual theory part and all those stuff that we have to learn about. So the very first part in Go routines, we have to first understand how we can spawn a Go routine and how the actual flow looks like when we spawn a Go routine. Okay. So let us take this code first. And my whole recommendation for you is pause at every step or like keep on writing your code on your terminal as well. And keep on finding out the outputs as we move forward in this particular video series. So what you can see here is like, can you tell me the output for this? It's pretty much simple. What you can see here is that what we have here. Let's take an example. So we have this particular line, like this is the inline like just printing out. So hello world start will be printed. Then this is the inline function, so which is invoked here itself. So then it will print hello world again. And then there's again print line, which is hello world end. So these are three lines and it will be printed in the same order because the program moved from top to bottom. Okay, so the answer will be pretty much simple for this. If I just check it out, if I just run this. So it prints hello world start, hello world end, hello world end. Okay, so pretty much simple here. Now, what is Go routine and how will spawn it? Go routine, you can see that what I've told you is like the program flows from top to bottom. And there's a single, you can say, go routine that is spawned here that travels from the top to the bottom. But now let's say I take this inline function and turn this into a separate go routine. So it's pretty much simple how you can turn it into a separate go routine. Whatever functions that you have, okay, whatever functions that you have, what you can do is that you can just turn it into a separate go routine by just typing out go in front of it. Okay, then that will be turned into a separate go routine. How you can visualize it? So let's say that when the function flows is going on like this, it will first print out this. Whenever it hit this point in the whole process of function call, it actually hits this keyword, which is go. And let's say you can just directly assume that it will start spawning. It will start creating parallelly at this time period only a different go routine that is also starting in parallelly just for this function part. So this function part is skipped in this particular call because it is spawned into a new like a new go routine, and the program keeps on moving forward. So this will like go here, and because this is the main function, this is just spawned, it is just started. This part is just spawned, just started. So the main function will actually go very fast and like print it out, and it will terminate the whole program. And because the termination is done, all the routines, because the main routine is terminated, so all the other routines are also terminated, and like this will actually not get printed out. So I'll tell you with the example as well. Let's say just print out this, and let's see. What you can see here is that now I spawned this into a new Go routine. It just print hello world start, hello world end. It doesn't have printed hello world again. Okay. So the thing is that the program starts and keeps on going like this. Whenever it hit this point, it's at this particular time, it spawns a new go routine. But because it's very fast, it goes till the completion of this function, till this is read and printed out. It just go to a like completion, and it just printed out, and the whole program stops, and this even doesn't get a chance to just print it out. Now, how you can do it? You have to somewhat give this some time. So before like terminating, just give it some time so that this will also get executed. So to give some time, you can manually give some time. So let's say you just give time.sleep of 50 milliseconds. Now what you can see here is that this line piece of code is telling the Golang that when you print out this particular line, before termination, before completing this main function, pause for 50 milliseconds. Like it's a very small time, but this time is still sufficient enough for this go routine to complete printing out. So it will first run this, and it will also print out in this like 50 milliseconds because it's a very small time, but still it will get some time to print it out this particular time. Let's now check it out. Boom. So as you can see, start and again. Again is in the end because it goes to the end, but it then stops for 50 milliseconds. And in that millisecond only, the other go routine completes its task and print out hello world again. Okay. So that's the overall like magic of go routines. It spawns, but it has to somehow wait. So that's the main problem, and we will be focusing on how we can keep these go routines in sync, so that if one completes his task, the other should also complete his task. It should not like you can say disappear in midway and should not complete a task. So all these go routines should be dependent on each other to complete their task and print out their task before the complete main go routine ends. So you have to like somehow coordinate them, sync them. So we'll talk about a lot of concepts in this series, but that's the overall very small crux of how you can spawn a go routine, how you have to wait for it sometimes to complete it out, and so on. So now in this, the whole problem is that I'm waiting for 50 milliseconds, but maybe it could have completed a task in just 20 milliseconds. I have wasted 30 milliseconds of like in runtime. Why? Because I do not know how much time it will take. So I just taken 50 milliseconds, but maybe it will take just 10 milliseconds and complete the task of printing out. And I'm just waiting 40 milliseconds more because I'm just thinking. I hope you understand. So we have to somehow sync these things so that we don't have to give manual time waiting. Okay, manual time waiting is very bad in the code part. We should not like explicitly tell to wait. They should coordinate between each other and tell each other that okay, I've completed, let's go and like stop the program. Okay, that we have to like manually we should not like manually maintain it like here. So we'll talk about how we can do it and all that stuff in this particular series. So if you understand this, if you still have any doubts, you can mention in the code part or like in the comment box of this particular video. I'll see you in the next one. Till keep coding and bye.